All right, chemistry, this is the day 56 assignment on solution stoichiometry. So you have the same cover page that you had on the last two assignments. So always refer to this when you need a definition. Okay, let's go. So 1A, we're going to do the A problems here. So we'll start with this one. So what is the molality of lead ions in the solution that is 400 parts per million lead ions? So you need to find. Okay, so we're going to come over to the sheet, look for molality. There it is. It's moles of solute. Oh, that would be the lead over kilograms of solvent, not solution, solvent, and that's the water, H2O. So we're going to come back here and write that over here where we want our answer. Okay, and it says, what is the molality of lead ions in a solution that's 400 parts per million? That means for every million grams of solution, you have 400 grams of solute. So we're going to write that over here. Okay, and again, we got that from right here, grams of solute over grams of solution. That's the solute and the solvent mixed together. So that's the lead and the water added together. All right, so on the top, let's look at what we have. We have grams of lead, and we need to get to moles of lead. That means we're going to need a molar mass conversion. Okay, so here we see we have lead right there, and it's 207.2 grams per mole. So now we're going to go back and write our equivalency. Okay, so here's what we need to know. We need to know the grams of solute, not solution here. So how do we get that? Well, the grams of solute, or solution rather, is the lead plus the water added together. That's the solution. I'll just write that up here. That's going to equal the grams of lead. It's going to be the grams of solvent. That's the water. So let me just write it as water, H2O. It's what's doing the dissolving. Plus the grams of lead. You add those two together, you get the grams of solution. So we know the grams of solution, and we know the grams of lead. We know this, and we know this. So if we take this and subtract this, take 1 million and subtract 400, that'll give us the grams of water. So grams of water is going to equal 1 million minus 400. You can do that on your calculator, and you get 999,600 grams of water, H2O. So now we have a relationship that for every 1 million grams of solution, that's this number, we have 999,600 grams of H2O. So we need to get to kilograms. So we want to get from kilograms of water. So we want to get from grams of solution to grams of solute, that is of water. So we do that first. And so the conversion very simply is this. So for every 1 million grams of solution, we have this. Okay, that's the relationship. All right, so grams of solution cancels. We now have grams of H2O. We need to get to kilograms. So we have the three fundamental conversions. 1,000 grams equals a kilogram, 1,000 milliliters equals a liter, and 1 milliliter of water equals 1 gram of water. So the one we need is the first one, and that's going to be, we need grams on the top, so 1,000 grams for every 1 kilogram. And that's true of anything, but we're interested in H2O, so that's why we're putting the substance as H2O. So grams of H2O, grams of H2O. So we have, and we have not yet done our molar mass conversion. I didn't do that. You could have done that first. So So actually I took care of the bottom first. We now have the correct units for the bottom. Now we got to get grams to moles, and we can do this. Usually you do this one first, but it really does not matter. So I'm going to put this. I need to have moles on the top. Okay, so now we have everything set up. So moles, grams of PB here goes way over here to grams of PB cancels. So we have moles of PB on the top. We have kilograms of H2O on the bottom. So everything is set up properly. So it is going to be 400 times. Now one other thing you can do, as you can see, just now you can cancel a million and a million, so you don't have to mess with those two numbers. So it's going to be 400 times 1,000 times 1 divided by 999,600 divided by 207.2, and that gives us 0.002 for molality. So it's this 0.002 of these units, which is molality. It's small m, and I'll write it like that. Okay. Okay, 2a. What is the mole fraction of sucrose, the sugar in a solution that is 5.84 molal sucrose? So that means molal means molality. So you come over here, it's moles of solute over kilograms of solvent. As always, the solvent is water. So we're going to write this. Well, it wants to know mole fraction, okay? That's dimensionless. So I'm just going to write equals a line. It's just going to be a decimal number. Could be it's called mole fraction, but it comes out with a decimal number. It doesn't have any units to it. So we're going to start over here. Okay, so that's what molal means. It's moles of solute over kilograms of solvent. Okay, so we have moles of solute, kilograms of solvent. Now a mole fraction, let's write down the formula for it. I'm going to do that here. It's going to be moles. Okay, so it's moles of the solute over moles of the total solution, which is everything, the solute and the solvent. So what we need to do is, whenever you deal with a mole fraction problem, as well as a percent composition by mass, anything where you have to add two numbers, you can't just do a nice straight across stoichiometry problem like we've been used to doing. So what we simply have to do here is figure out what are our moles of sugar. Well, we were given that. It's 5.84. So we know this number and we know this number, but we don't know moles of H2O. So we're going to have to figure that out. I'm going to come down here. You need to use this space, so you should probably do this on lined paper. Let's figure out how many moles of H2O we have. So it's going to be 1 kilogram. You're going to do that as a separate stoichiometry problem of H2O. So let's first figure out how many grams that is. Okay, so we've kilograms and kilograms. Now we have grams of H2O, but we need to get that to moles. So we have 1,000 grams of H2O. The molar mass for H2O, here's the equivalency. Okay, so we need grams of H2O to cancel, so it's 1 mole. So grams of H2O, grams of H2O. So now we have moles of H2O. That's what we want to know. So it's 1 kilogram times, it's 1 times 1,000 times 1 divided by 18.02, and that's going to give us 55.5 moles of H2O in 1,000 grams. So now that number is this. So now we know all three of the numbers we need. So we're going to write it as this, the mole fraction of the sucrose. So I'm just going to write SUC there rather than that formula again, equals I'm not including units of measure because they're all going to cancel out. Moles, and you're just going to end up with a dimensionless unit. The way you do this on a calculator is it's 5.84 divided by what's on the bottom. So you put that in parentheses. 5.84 plus 55.5, close the parenthesis, and hit equal. What that means is it's going to add the two things in the parentheses first. That's PEMDAS, parentheses come first. and then it's going to do the division, which comes second. So it's the 5.84 divided by all of that added together, and that gives us 0.095. And again, moles canceled out, so that's it. It's not expressed as a fraction, it's expressed as a decimal number. Okay, let's go on to 3a. Okay. And by the way, Davis is just a source where I get the problems from. It's a note to me where I got this problem from. If 1.5 liters of 5 molar solution of sodium chloride is diluted to 6 liters, what is the molarity of the new solution? In other words, your lemonade is too strong, so you're pouring water into it to make it weaker so it's not as sweet and syrupy and it tastes right. That's what you're doing here. So these are very simple. You go to mole fraction, dilution. It's down here. It's M1V1. You should correct that V1. On some of the sheets it says V2. That was a mistake. So it's M1V1. That's the molarity times the volume before you've diluted. That's going to equal the molarity times the volume after you've diluted. Okay, so now we can just plug in the numbers. Before is the 1.5 times 5. The volume is 1.5 liters. And the molarity is 5 molar, so it's 5m. This is the one time where you don't have to convert M, capital M, into moles of solute over liters of solution. You can just cancel it directly. So it's the only time you shouldn't do that. The molarity after, the volume after, so V2 is going to be 6 liters. So they want to know what concentration that is, what molarity. So that's M2. Okay, so if I come over here, I'm going to divide both sides by 6. So I get M2, the molarity after, equals. So liters and liters cancel, so you end up with molarity, and that's what you want. So it's 5 times 1.5 divided by 6, and that's going to give us 1.25 molar. So you've made your lemonade weaker. It's gone from 5 molar down to 1.25 molar. It's less concentrated. Okay, I'm dealing with some disk space issues, so I'm going to wrap up this video and do the rest of the problems for this assignment on a second video.